Day 132, Honors Physics, homework problem number 25, Electrostatics. On the left over here, I have the diagram of the three charges on the vertices of an equilateral triangle, each of length 60 centimeters each side, and then we're looking for the electric field strength at the centroid of the triangle. Now there are some shortcuts here, but I did some of the preliminary work. If I just look at the geometry of the triangle up here in the overhead on the right here, all right, you have 60 centimeters on each side. I left off the units there for now. But if you draw the three diagonals, so to speak, parts of the altitudes, I should say, this one, it goes to the centroid, this altitude, all the way down would be the altitude, but this would be the centroid. I'm looking for that. I'm looking for the length of this blue segment right here, and there's three of them, but I'm going to look at this particular triangle to be specific right now. And I know in an equilateral triangle, each of the original angles are 60, but if I split the angle right here, this theta, this blue theta right here, is 30 degrees. And I know that this segment right here is half of 60, that's 30 centimeters. And I know you could use 30, 60, 90s to figure out this black segment right here is actually, well, it'll be 30 over root 3. And then if you take that and double it, you would get d. Or you can just use cosine of theta, would be 30 over d. That's what I did down here to figure out that d is 35 centimeters. That's how far it is from each vertex to the centroid of the triangle, this spot right here, going back over here on the left. So in other words, if I want to find three fields, I have three fields. Now, once again, I would draw it like this. And there are more shortcuts you could have taken in this problem. But bottom line is you'd have one field that's pointing, I call it E sub 1. That's pointing towards that negative charge if you ignore the other two. Another field pointing this way, E sub 2, but it will be equal to E sub 1, and it will be equal to E sub 3. All three of those are equal to each other. The nice thing here is there's some symmetry. You could have taken some shortcuts, but you'll see that they're all going to cancel out. But bottom line is, if you actually calculated them, each one would have been, or are, 9 times 10 to the 9th times the 25 micro divided by how far it is from each corner, which is 35 centimeters, or 0.35 meters squared. So you could figure out E sub 1, E sub 2, and E sub 3 as that numerical value. But once again, if you go through the vectorial analysis, the analysis of the vectors here, you're going to find out that all three of these will cancel out and get a net field of 0. It'd be much more difficult if, say, the top point up here would have been, like, say, a positive 25, in which case this arrow right here would have been down instead of up, and then they wouldn't have canceled. So you would have had a down vector right here. It wouldn't be that hard, but it would be a little bit more work than just saying 0 right now. These cancel out in Part A. So Part A turns out to be pretty easy. Part B is one step more difficult, as you'll see here in a second. So you could just say, in other words, in this problem, you could figure out E sub 1 if you wanted to, which is equal to E sub 2 equal to E sub 3, and then you could just say, well, they're all going to cancel because of the symmetry of the problem. You don't need to go any further than that. But in the next one, Part B, they don't cancel. Let me go to Part B. So they're asking for in Part B here at a location that's the midpoint of one of the three sides. So I've indicated that with an X right here, so I'm at the midpoint on the bottom side, but it'll be the same on any of the three sides, so I only need to deal with one. But once again, there are three fields there if we take them one by one. If you take the lower left-hand charge, the electric field due to that charge alone will be this way. I can call that E sub 1. And then the lower right-hand charge, the other negative 25 microcoulombs in the lower right, would have an equal field, E sub 2. And since it's the same charge, same distance, like I said, it'll be equal in size. Those are going to cancel, so we don't need to calculate those. So you can make the argument already that that's going to be 0 for those two. Bottom line is all you have left is the field this way towards the third charge at the top, E sub 3. Now, E sub 3 is different than E sub 1 and E sub 2 because now you're further from that. And I have a diagram over here in the upper hand right to figure out this hypotenuse, or the altitude, it's not a hypotenuse, of this triangle. Basically, the distance from that top spot up there to the midpoint of this bottom side turns out to be 52 centimeters. You could use Pythagorean theorem, sines or cosines, trigonometry. I just used the shortcut for a 30, 60, 90 because the short leg here is 30. The longer leg of the 30, 60, 90 is 30 root 3. So then you just, basically, that's the entire problem now. E sub 3 is going to be the final answer, because that is the net electric field. It's just going to be 9 times 10 to the 9th times that 25 micro divided by that distance squared. And that will be your answer, because the other two fields, the E sub 1 and E sub 2, cancel out.